All right, ladies and gentlemen, we're going to reconvene here, getting towards the end of the day, but still exceptionally valuable material to cover. This section will look at case study examples of coastal engineering, and Moritz and David Michalsen will be giving us a talk and then a panel discussion. Please.
Thank you, and thanks for inviting Dave Michalsen and myself to present to you today about some of the infrastructure requirements we have to meet with the Corps of Engineers. The outline will be 5 elements to this talk. 2 of the elements will be an introduction dealing with, first, what is the mission of the Corps of Engineers to support our nation's infrastructure requirements for civil works, and then our culture and how we can align for alignment of collaboration. And then the next 3 elements will go through the activities that the Corps of Engineers has relevant to the coastal margin and NANOOS and the Pac Northwest for Portland District and Seattle District Corps offices. Then we'll address the challenges that we face along our coastal margin, dealing with coastal navigation infrastructure, specifically the aging infrastructure. And then we'll summarize with some opportunities. Our Civil Works program, Corps of Engineers, is supported by about $5 billion annually. It's a diverse portfolio of 7 missions. But today I'll be specifically talking to you about navigation along our coastal margin. Overall, the ports and waterways that the Corps is involved with have a lot to do with our nation's economic health. And waterborne commerce is, by far, the most efficient way to move commodities. The Corps offices are represented by regional commands, named divisions, and each division has a number of districts that support the division. Also shown here are the regional associations for IUs. In this part of the world, the regional command for the Corps of Engineers is the Northwestern Division, and I'll be addressing the Seattle and Portland districts' infrastructure today for you. Our culture, the Corps is mission-oriented and project-focused. The Corps obtains data for our immediate project needs, and we're somewhat limited from obtaining other types of data that don't fall within our immediate needs, in this case, supporting coastal navigation infrastructure. I want to emphasize that sometimes the Corps does not fully exploit or advertise the data that we collect. However, on the good side is that we're execution-driven. We're very good at aligning resources to complete the task at hand. We can use this energy to collaborate with others when their tasks overlap with our tasks. We are undergoing a cultural shift in the Corps, though. We're trying to leverage resources across projects, looking at a systems-based approach. Bottom line today, for today's talk, though, I wanted to emphasize is our coastal navigation infrastructure has increased vulnerability. We need to address this by improving our adaptive management decision-making. To do that, we need a good data feed. So bottom line is we need to share and utilize existing data sets as much as possible and the combined capabilities for observing, collecting, and analyzing future data sets. Portland District has 11 jettied inlets along its coast, and we also operate 20 dams. Here's what a dam looks like. It's a complicated system of infrastructure. And then an inlet. This is Newport. It is also a system of infrastructure. These 2 business lines end up competing for scarce resource maintenance dollars. So we have to make some hard decisions. The synopsis of our coastal navigation infrastructure is that through Portland District's ports, we convey $18 billion in waterborne commerce each year. 11 jetty inlets compose 30 miles of structures out into the ocean, $2 billion of investment, and we're basically having to adaptively manage these elements by basically doing just-in-time repairs to keep things from failing. We want to keep the function, but we don't want it to fail. And to do this requires frequent observation of forcing processes and responses. So when we take an inlet from its natural condition to an engineered inlet, we're basically investing a lot of money up front to construct jetties and training structures and then follow on dredging maintenance activities. It ends up being a system with the channel as the centerpiece of the system. However, the morphology at the inlet is really what's going on. And we're working with nature to maintain the morphology which supports the jetties and sustains the navigation channel as a system. These sorts of systems are subjected to severe loading every year We get in the Pac Northwest what is equivalent to a hurricane. Same scale, the bottom panel is a hurricane that's hitting Louisiana. Wave modeling and data. It's essential for understanding how our coastal infrastructure adapts to its life cycle. In addition, we need wave data. I think all of us need wave data, but the Corps also, to make informed decisions regarding navigation, utility, and safety. We highly utilize the CDIP and NDBC wave buoy data, real-time observations, and we really make the best use of shelf and nearshore bathymetry data. We can't do wave modeling without good bathymetry data. Here's a comparison of 3 different models, wave models, to estimate wave height. And in some places, the wave models agree, and other places, they do not. Now, this diversity in model results is actually helpful, because by comparing models, we can reduce risk and uncertainty. It informs us about processes we may not be having fully defined, and it improves collaboration, especially when different groups are doing the wave modeling and we're comparing results. Jetty loading, waves, it can be very severe. We can go from a fair condition jetty to a threatened condition jetty in just a matter of a year or 2. So we have to maintain surveillance. In addition, where the jetties connect to shore, water level comes up, storm surge, those vulnerable parts of the jetties can fail. As you see here, a small breach opening resulted in the release of a significant amount of morphology into the inlet. And then the last slide before I transition over to David Michalsen is this. This is a time-varying reliability plot for, for a given jetty. And it starts basically when the jetty was begun, and then it's going through time to the present day. And you can see that the reliability has changed through time. Different repair scenarios, different times when the morphology came out in response to the jetty construction, it protected the jetty. Now that morphology is receding, exposing the jetty to more vigorous ocean loading, and now we're in a state where the reliability is not so good. It's poor. And we are dealing with vulnerable infrastructure. This type of evaluation requires extensive integration of observed wave data, water levels, wave model results, bathymetry and topographic data, jetty design equations. It all comes together from different elements, core elements, and different data suppliers that we use. David Michalsen, I'll take over. David's with Seattle District.
Thank you, Rod. So as Rod mentioned, it's part of our maintenance. We do need to continue O&M dredging from annual year-to-year operations. So this is just an example of our dredging at our MCR, Columbia River. And basically, our inlets on the coast is a combination dredging by government hopper dredges as well as...
Can you microphone? Can you guys hear him in the back?
I'm sorry. Is that better? Okay. So as I was saying, we're required to dredge annually at our inlets, and here's a schematic of a private dredge and a government hopper dredge. And in order to make educated decisions about what the shoaling is in our harbors, we need advanced knowledge on these complex processes, how channels shoal in, and where we should be placing our dredge material to make most beneficial use of the sediment. And to do that, we need environmental forcing data such as tides, waves, currents, and wind data. This is an example of a split-hole hopper placing dredge material by the North Jetty at the Columbia River here, and these type of data help inform this decision making to still maintain safe navigation and minimize impacts on ecological species. So as I said, we are all stewards of the environment, and in order to work within that environment and minimize the challenges we face with accomplishing our mission of maintaining our navigation channels, we need to work together collectively with our resource agencies and fisheries to minimize these impacts to ecology, and at the end of the day, it's going to benefit everyone. I'll transition into Seattle District infrastructure now. We have projects that are on outer coast, mainly 3 at Grays Harbor, Quileute, and also Willapa Bay to the south, and the 2 in the Strait of Juan de Fuca, and then 17 in Puget Sound. This graph on the right-hand corner just describes a general breakout of commercial cargo, fisheries, and recreation. Seattle, Tacoma are the main economic commercial cargo ports, but it's important to note that commercial fisheries on the outer coast at Grays Harbor and other harbors, Willapa Bay, are also important contributors, and these are all stakeholders at our projects. As a tie into what Rod talked about earlier, our infrastructure is aging, and also the processes that are forcing on this infrastructure are changing. It's non-stationary. This is just an example of a wave model at Grays Harbor from 1999 to 2008. In that 10-year period, the channel morphology in the harbor throat scoured out a very large degree as a result of this Damon spit accreting and growing to the south. As a result, it refocused some of the wave energy on our O&M infrastructure seen here at Westport, and we've noticed quite a bit more wave energy hitting the structure that it was originally not designed to withstand. So these are the type of issues we're facing, and we need to evolve along with the processes that are forced on our structures. Other missions we deal with are flood damage reduction. Here's a project at Willapa Bay that we were working with the stakeholder, the Shoalwater Indian Reservation. It's a small area here, and they've seen massive erosion to their protective barrier islands out in front of the reservation, and we engage in a multi-agency study here with USGS, Ecology, and our Engineering Research Development Center out of Vicksburg to look at if there was an actually feasible plan to where we could minimize this flooding risk to the reservation and erosion of their land. And we determined that the geology did prove to be, in fact, capable of providing this through this hard point, act as an anchor here, and determined that barrier island restoration could have a positive impact on the reservation. And in order to make these type of decisions, we need geological data along with hydrodynamic data, namely water levels at Toke Point were key in determining what the storm surges were and waves offshore at the CDIP buoys. And we were able to look at scenarios and just look at different risk reduction scenarios where we could have a positive impact on flooding in the reservation. One thing to also point out is that coastal observations also serve a broader user base, inland flooding as well. One key thing was a crisis that we had at one of our dams, Howard Hansen, just 2 years ago. After a large January storm, a depression was found in the abutment, and we had to have a better data to make decisions on how to operate the dam. So there wasn't a crisis with the dam failure itself. We needed to know what was coming so we can make better decisions about how to operate the dam to reduce the risk of a catastrophic impact to the infrastructure. So there was a atmospheric river observation station put out at Westport, and this was a key collaboration between the Corps' meteorologists and National Weather Service and NOAA's environmental research group out of Boulder, Colorado, and they installed this to get better wind profiles on these atmospheric river events. That's just an example of this. So just the key data products and needs that the Corps works with. Wave buoys, water levels are key ones. Argus webcams give us more information about how that offshore wave data that's at the buoys comes in and how it impacts the actual coastlines and the harbors. Like people have said, WaveWatch 3, ET Surge, all these models capable of providing real close-time data to make decisions on how, if we need to respond to some type of event beforehand to prevent a more catastrophic failure scenario. What data is needed? More water level data, more spatial temporal coverage. This is going to be an issue as sea level change issues become more at play. I would say this network needs to be expanded more into inland waters, Puget Sound particularly, where vertical land movement is highly variable. Same thing for ecosystem restoration, where tidal hydrology restoration is a driving factor of the management measures. Wave buoys, similar, expanding the network, short-term instrumentation for tactical deployments. And then just understanding episodic events that drive sediment transport. These are all regional sediment management type of answers and questions that we have, and we can learn from examples at the mouth of the Columbia River to implement to other systems such as Puget Sound and other harbors on the outer coast, Grace Harbor, Willapa Bay. This is just more detail here of data needs that basically the main themes are hydrodynamic, sediment transport, climate change, and temporal and spatial resolution. I'm not going to go through all of these, but they're here. So just in summary, opportunities to collaborate with the Corps. We have in-house resources that U.S. Army Corps staff can interact directly with stakeholders. We have contracts where we can work with private industry with government orders that allows us to work with other federal agencies and cooperative agreements that allows us to work with universities and state entities, local governments. Concluding remarks, the Corps has been active in partnering with NANOOS principal investigators on various projects. We have a diverse set of stakeholders, both federal, tribes, state, local, private industry, ports, resource agencies, and NGOs. As Rod mentioned, we're execution driven, and a lot of the data that we have collected may not be known to a lot of our stakeholders, and NANOOS can be a good segue on how to incorporate that to broader use. So I think we need to look at some of that, how we can feed some of that data that we've collected into the network. And then coastal engineering, future focus areas and opportunities. I think planning and adaptive management for coastal infrastructure is really key. We have prime examples on how it's going to look, and we need to engage and make sure we have the data in place to do that effectively. And then renewable energy, I just want to state that the Corps does have a lot of knowledge and historic knowledge about morphology and inlets and wave dynamics, and we can work together potentially to reduce some of that duplication of effort. So that's all I have. So thank you.
Hans and David, thank you very much for that very illuminating discussion of Army Corps of Engineers attributes, capabilities, and needs. And now I'd like to open it up for questions for these two gentlemen. I have one. As regional representatives of the Army Corps, do you believe that there is strong buy-in by senior Corps leadership to, in fact, encourage the Pacific Northwest entities in the Corps to become more actively involved with this particular RA and in general? Is that something that the Corps wants to do nationwide?
Well, we're here. Actually, let me introduce, Brad Bird, who is our division leadership for all of hydraulic engineering in Northwestern Division, is here. Brad, can you identify yourself?
Yeah, that's me, and the answer is yes. And we've got a name, and we'll get it to you. So the chief engineering from Portland District will be our member or whatever, and yes, we will. That's why we're here, and we've got commitment from our senior leadership, and the general is aware but really unavailable to be in that position, but next best thing.
Fantastic.
Fantastic. I congratulate the Army Corps on that. That's the kind of leadership that speaks well for our federal agencies.
So I want to echo, the Army Corps has been an absolutely strong partner. They've got a liaison officer in our U.S. National Office. It's our only other federal partner, and General Temple and General Walsh, who are at headquarters at Army Corps, are on board with this, and I have the opportunity to speak with them regularly. So it's been a tremendous partnership, and I'm glad to see that that's been the aim of the Army Corps, to have their members fully involved in the regions.
I just have one of these. This was not a geeky question. It's one of those admin questions that, on a comment you made, that we've always understand the Corps of Engineers has always been mission-based and project-oriented. And you said that you're trying to go to a more systems approach to. And could you illuminate us on what does that mean?
You want to take a crack with RSM?
Yeah, I could try to answer that question. Well, we have our regional sediment management program, which basically looks at systems more holistically versus project-based. A prime example in this area is the mouth of the Columbia River littoral cell demonstration project, where Rod and the Lower Columbia Solutions Group have really interacted with various stakeholders to really take a better look at how we manage sediment at that inlet, and look at things on a more system-based approach than just we have to dredge the channel here. Where can we put this material? So yeah,
it's viewing sediment as something that's moving regardless of what project we're dredging or where we need to place it, and viewing it as a system, as a sediment shed rather than a project. And we're starting to move that way with some of the operation of other business line elements too. But it's slow. One thing about the Corps is that the adage about carpenters to measure twice and cut once, well, the Corps likes to measure about 4 times. But we're getting there.
In the spirit of the systems approach, is the Corps interested in relatively real-time wave and current and sediment transport capability on an hour-to-hour or day-to-day basis?
I think Dave and I and most of the Corps districts utilize the real-time observations for, in this case, coastal elements, waves. Yes, we are very much interested in that. And we during the wintertime, we're always looking at the NDBC regional assets and CDIP assets to seeing what's going on. We're looking at the Wave Watch 3 forecast. We're looking at forecast five days ahead of us. We do the same thing for the managing the rivers. We coordinate with regional meteorologists and seeing what the 10-day forecast is. Because a lot of our things we have to be able to respond real time. And so that's a good viewpoint of the systems management, is that the meteorological systems affecting our infrastructure, we have a big picture view on that. It's just in terms of the funding, the resourcing for specific projects. And if we have to fix a project element and we have the opportunity, we have a contractor on site, can we go ahead and fix another project element that's separately funded at the same time? It's very hard to do. And then data collection, new types of data that are coming online. Let's say we want to collect some wave data at offshore Tillamook. Is there a possibility we could bridge that with some other things going on that we know about? We can't put a wave buoy offshore Neskowin because we don't have a project there. But maybe if we could share that asset at Tillamook for 6 months and then relocate it as a tactical wave buoy to Neskowin, we can collaborate and get two things done.
Thank you for such a full answer.
Any other questions? Let me ask a follow-up to Chris Moore's question then. On the slide you had with the various data types which would be of extreme value to the Corps, a lot of those are collected by other agencies. Does the Corps then maintain an investment in observations like water level, or do you rely on NOS to provide those? And would you want them to increase their investment, or NANOOS or other entities, or can the Corps do that and keep them there for the long term?
I'm going to bring in Bill Berkemeyer. Bill is he's a agency asset for the Corps, and Bill, is that can I bring you in to answer? That's how we maintain our wave gauging.
Yeah, so let me try to answer that. And first, for this audience, I think one of the things that you guys are very fortunate to have in the Northwest here is some really great, knowledgeable folks within the Corps that care about this Northwest coastline, and a real knowledgeable group here. So it's great. It's great for us to present and realize you have here some really dedicated folks. The question on data is we have a program which I manage, which sustains wave observations. We fund part of the CDIP program, and independent of projects. And so yes, we've sort of focused on waves. So we don't do water levels, we do waves. You can hear we like waves. We're sort of a one variable. But we'll throw our wave information in, but we do need all these other data types. And one of the reasons we've been promoting IUS for a long time is because we look to people who know these other data types much better than us to help with that. So we'll put some on the table, but we hope there's some other things on the table to take away. And we're trying to sustain our wave information, and even that's tough under this tough budget things. But finding users and applications, that really helps justify it within our structure as well.
Thank you, Bill.
I could just add on top of that, locally, Corps districts work with the USGS, and they do a lot of our river gauging for us and some water levels, turbidity assessments. And so they do a very good job at that, and we bridge on to that. There's other opportunities where we do cooperative agreements or government orders with local agencies to collect data for us.
Well, this might be the opportunity to say that perhaps NANOOS and the other RAs could serve as a handy venue for regional entities of various federal agencies to come together and explore what these two fine gentlemen just said about data sharing and opportunities for collaboration. I hope that that would come to pass. Any further questions for our Army Corps professionals here? Then thank you very much, guys. Our last case study example of the day, but by far not the least, deals with hazard response and marine operations. And we are pleased today to welcome Commander Michael Schoonover, yes, and Captain Dan Jordan, captain from the Columbia River Bar Parts Association, and then Amy MacFadyen. And are you going to do this together, or we'll just do it sequentially here, right? Okay. All yours, sir.
Okay. Well, good afternoon, everyone. I guess we are up for the final session. I think you'll see a transition here with this last session. Many of the talks up till now have been very theoretically based, a lot of large words and lots of data up on the screen, many of which were over my head as an operator and not a scientist. where I'm going to bring it down to with my talk here is a discussion about the tactical use of a lot of the data that's out there that's being produced. The Coast Guard specifically is a great consumer of data for a lot of our Coast Guard operations. We produce very little of it, but that data is critical for the ongoing Coast Guard operations that we run every day. So I'm going to talk specifically about Sector Puget Sound, and I'll cover a little bit this region that actually encompasses. But the topics that I cover also apply to our two Coast Guard sectors that are to the south of here that also make up the Pacific Northwest region. Those would be sectors Columbia River and soon-to-be Sector North Bend, right now Group North Bend. So again, I'm the response chief at Coast Guard Sector Puget Sound. We run all of the Coast Guard missions up here in Puget Sound with the exception of ice breaking. Unless things change here soon, which I hear they're not getting any more ice, we're getting less ice. Not going to be a lot of ice breaking up here, but other than that, we do search and rescue, maritime homeland security, protection of natural resources, which also includes oil and hazmat response, maritime safety, and national defense. The environmental products that are out there, the data that's out there, contributes to the Coast Guard's ability to execute all of these missions. Just a little bit about the unique AOR up here, and for any of you that operate on the water, you definitely know that this is a very diverse geographical environment. From offshore, the area off of La Push, into the Straits of Juan de Fuca, Puget Sound, up in the San Juan Islands. The operating conditions in any of those areas are completely different. And so when we're running missions out on the coast, the information that we need and what assets we're going to be sending differ greatly than when we are responding to a case up in the Schoonover Channel. This slide also just shows how large of an area it is. This is an overlay of the different Captain of the Port zones for some larger ports in the Coast Guard. And you really get to see, certainly not an indication of volume, because all of these other ports run a lot of volume, but pure size-wise, this area encompasses a very large area. And how we overcome that large area is consolidating all of our operations into one command, control, and communication center, which is located at Pier 36 in Seattle, the Puget Sound Joint Harbor Operations Center. For those of you that have not had the opportunity to come down there, we routinely host tours for all different types of groups, industry groups, government groups, as well as different just general organizations. So my contact information should be with the NANOOS point of contacts. If you ever want to come in for a tour, we'd love to have groups come down there. As you see here, lots of computer screens, lots of sensors, kind of information overload, and so our job there is really how do we consolidate all of that data into a usable product. One of the ways we do that is through our what's called the Common Operating Picture. We integrate visual sensors with the cameras you see on the left and the right, infrared, radar, satellite imagery, weather data, and all of that comes into kind of one consolidated picture that gives us an idea of what's going on in the region and then how do we respond. So with that as background, I could have used any of our missions as an example of how we integrate environmental data. I thought search and rescue would be an interesting one because generally a lot of folks hear and see that on the news day to day. We run a lot of search and rescue operations in this region, generally anywhere from 600 to 700 cases a year. So how we use environmental data for search and rescue kind of varies depending on what type of a case it is, but I really divide search and rescue into two phases, the search phase and the rescue phase, appropriately named. The rescue phase is actually pretty straightforward. It may be the most dangerous phase, but once you know where the person is, the boat is, or exactly what it is that you're looking for, going out and rescuing it is just a matter of selecting the best asset. And so really what we're using the environmental data there for is to determine, based upon the prevailing conditions, wave height, sea conditions, visibility, current, whether or not we need to send one of our small boats, whether or not we need to send one of our larger cutters, our helicopters, or some of our fixed-wing aircraft, really, because our sole mission there is we want to be able to safely pull that person out of distress or that vessel out of distress without unduly endangering our Coast Guard members. So with that, really, it's just a matter of getting real-time information as well as good forecasted information so we can send our crews out there with all the right information. The search phase is actually a little bit more complicated, and we use some pretty sophisticated modeling software that uses a Monte Carlo simulation technique to do just that, to project based upon our known assumptions. Sometimes we may know. In this case, this is actually a run using our modeling tool where we had a person fall off a ferry. And so we had a pretty good idea of where the initial datum was, the initial start of that search was, but then there were wind, current conditions pushing that possible person in the water. And so as we did subsequent searches, the system, or the software basically modeled where that object in the water would drift. That's very different than what we often see offshore, which is a vessel that's reported leaving one place, not arriving somewhere else, what we call an overdue. There's a large degree of uncertainty in there because we actually don't know when that vessel went into distress. And so sometimes the area that we'll be modeling might be 20 square miles, 50 square miles, 100 square miles, and the uncertainty grows exponentially as the search area increases. And so there, the data that we're feeding into that model, which to a large part is all of the historical environmental data we have, plays a critical role in our ability to locate whatever object we happen to be searching for. But once basically we have that drift rate and the software models exactly where the object that we're searching for would drift to, then what it does through an optimization process is determine basically, based upon what assets we have out there searching, the best search grid to go on in order to find whatever it is you're looking for. And that's what you see here with those patterns back and forth. Those would be the type of patterns that our aircraft and our small boats and our cutters on scene would have been searching. So I could talk forever about search and rescue. That's what I grew up in the Coast Guard doing. I love it. But just real quick here, oil spills. Oil is near and dear, of course, to protecting the area here in Puget Sound, very sensitive area. And so as we use the environmental data to do our our search and rescue analysis, we also use it for our oil spill analysis, leaning heavily on NOAA and our scientific support coordinators to determine trajectories of oil as well as fate of oil for the larger spills. This happened to be just a very small spill off of West Seattle, but good visual. With that, I'll turn it over to my panel members here, but just ending, this is off of La Push, that buoy that people talked about earlier today, critical buoy for our surf stations there. Actually, they get to go out and have fun when everyone else is staying in. I had the opportunity last Thursday of being the guy on the front boat with a big smile on his face as we were shooting through that wave. But they're one of the few teams that when things get nasty, that's when they like to go out and have fun.
David announced our next speaker is Captain Dan Jordan.
Good afternoon, everyone. I'm a firm believer in picture tells 1,000 words. If you'd rather read, there's a fact sheet in the back of the room. So the Columbia River Bar is where I work. I have fun in those waves as well. It's worth noting before I go on with this that Columbia River is the third largest grain export gateway in the world, #1 in wheat exports in the nation. Handles 42 million tons of international cargo valued at $20 billion annually. So quite an economic engine. When we have rough weather out here, it shuts it all down. Trains, barges to Idaho, shuts the whole system down and costs a lot of money. So that's where we rely on your data to keep it going. There's also a vibrant crab industry and fishing industry as well there, and can shut them down as well. So the Columbia River, 100 miles, 4 competing independent ports, from Portland, Vancouver on down to the river. In order for us to sail a ship out of Portland, we have to have 10 hours lead time to set up tugboats and line handlers coming down the river before it crosses the bar. So we use real-time data off the wave buoys and discussions with the National Weather Service as well to make that decision to sail the ships down the river. But once they go, there are no suitable anchorages in the river to stop a deeply loaded ship. So those forecasts are really important to us. The wave height can be off a little bit, which it is quite often, but the timing is critical. And that coastal radar, the new Doppler radar, has really improved the timing of the forecast. We're really thankful to have that there. So here's all the buoys. You've probably seen lots of different slides of these. These are rough numbers that we look at, though. I was a ship's captain before I was a pilot, and ship's captains always have to second-guess forecasters. It's just in our nature. So we look at the wave buoys as well, and you can look at a buoy and say, well, roughly 18 hours from the wave at this buoy, it's going to be at the bar, and it gets to the next buoy. Is it really happening? So the NDBC buoys, they were critical to us. But for a lot of years there, they weren't surviving the winter. Rod showed you the hurricane force storms that came here. And either they would not transmit their data or they'd break loose their moorings and disappear. And then we couldn't get them back on station until the summer. So we're all winter, the most critical time with no data. So in June of 2009, we had, I've heard a lot of conversation today about collaborative partnerships. We had a wonderful collaborative partnership. 2009, we got together and tried to identify what's going on with these buoys and what can we do. The outcome of that was wonderful. NDBC modified the moorings of their buoys and the communications package on their buoys, and they've been surviving the winter now. That's great. The Corps of Engineers funded a C-dip wave rider buoy that we put in really close to the bar, giving us real-time data for the bar. Very, very helpful there. And they were wonderful. Kudos to the Corps of Engineers on that. They had funding for the projects that Rod spoke of today, the regional sediment management, the jetties, the infrastructure. But they talked to all the interested parties, ourselves, the fishing fleets, the crabbing fleets. We were able to place that buoy in a position that worked for them and for us. So that was very helpful. Here's a before and after storm. And these are the C-dip wave rider buoys, which we have 2 out there now. The Corps of Engineers funded the inner one, and the bar pilots we got a grant and funded the outer one off the continental shelf there, so that the idea is the data from both of them, one measures waves where it feels the bottom, the other measures the waves where it doesn't feel the bottom, and you can come up with a better wave forecast that way. I don't come up with a wave forecast, but you have National Weather Service. If this helps them, then wonderful. So the placement of that outer buoy, we funded it, but we let them choose where to put it. And hopefully we get better forecasts. We've been seeing some great improvements from that. So here's another placement idea. That one issue that we have, it's the inshore wave rider buoy there. The currents out of the Columbia River can be extreme at times, 6, 7 knots. That plume goes out 11 miles from the Columbia River entrance. Any more than a 2-knot current in that wave buoy goes underwater, doesn't transmit anymore. So we're not getting actual waves on the bar from that buoy. We're getting as close as possible and then letting the modelers try and model it, which also takes real-time current to be able to do that, which we don't have either. So for those of you that would like to model the real-time current or measure real-time currents out there, we're all open for it. So here's from the NDBC site. They have this available for all the buoys that are out there, and we look at the peaks. We watch a storm coming in like that, and at a certain point we decide we can't take a ship out. We don't operate the ships, and all the trains and barges upriver start complaining. When we watch the storm drop off on the other side and waves get back into our operating levels, then we can start running ships again. But remember, we have to give them 10 hours notice for that. So that's a real challenge. Forecasts are real important. And this is just a great slide because there were 2 storms. We had a little window we could move ships, and the second storm came in and we had to stop moving ships again. We've Scripps and the National Weather Service have done great jobs of tailoring their products to us on the websites. This is off the Scripps website for the C-dip buoy program. It's a 30-minute sample of all the waves that occurred at that buoy. So we get significant wave heights from NDBC buoys, but we can get, this shows the upper 10% in the maximum wave, and the full spectrum. So before I get on a ship and cross the bar, I can see what I'm going to encounter. If the maximum wave, like in this case, was 30 feet, I look in, are there a lot of waves near it? Do I have to worry about a whole lot of big waves, or was it 30 foot and then the 22 foot was the next lower one? It helps me decide what I'm going to get involved in. This is another slide from the Scripps site. That outer wave buoy, not only is it off the continental shelf to do that comparison, but it's also right on the border of the WaveWatch 3 model and the SWAN model, so it helps the transition from one model to the other, which is providing a lot better modeling for us on the bar. And you can see there's differences there, but it's fairly close. Now we get into the visuals. This is true to scale, a ship coming down the Columbia River, 3 foot between the bottom of the ship and the bottom of the channel. So we really pay attention to the tides as well. So what this is a lead-in for is another collaborative partnership that we did. Part of that grant, we've started what's called a dynamic underkeel clearance program. So you can tell, looking at that picture, you really don't want the ship to move at all and hit the bottom. If it does, you want to know how much it moves. So this is what we're doing now. We're currently in the process of this study and bringing in lots of collaborative efforts on it. We're measuring each component that makes the ship move. Water density, tide, the squat, which is how the ship settles when it's moving, heel, and the wave response. I'm running out of time? Okay, I'll move on. So there are a lot of people are leading into that. And we've also learned different tide datums there. A lot of different tide datums on the river. And this is a bar forecast model that OSU has done for us. The top one there showing the blue line is at the wave rider buoy. The red line is modeled for the bar, taking the currents into effect. Each one of those dotted lines is now 3 hours from now, 6 hours from now, 12 hours from now. And we get something like this from each one of those dotted lines, which is very helpful. And wave response is the largest thing. So I'll leave you one last thing. That's a picture of a ship going across the bar, and you can tell how much underkeel clearance we're losing on that one pretty easily. Thank you.
And Amy's next.
Were you on board? I was.
Thank you, Amy.
Thanks, Jan, and thanks for inviting me to be a part of this today. It's been really interesting, and happy that you all stayed for this final session. I'm here representing the Emergency Response Division of NOAA's Office of Response and Restoration, which is part of the National Ocean Service. We're also known by our old name, which is still used frequently, which is NOAA Hazmat, maybe more familiar to many of you. The origins of our program are in this figure in the upper right, the Argo Merchant, which was a spill which threatened the Georges Bank fishing area back in the 1970s. Obviously, it was there was a lot of attention on it and a lot of sensitivity and a lot of conflicting information. So I believe the Coast Guard asked NOAA to engage and be their scientific liaison on that spill. And since then, that relationship has been more formalized, and under the National Contingency Plan, NOAA has the responsibility for providing scientific support to the Federal On-Scene Coordinator for Oil and Hazardous Material Spills, and in the case of marine oil spills, the Federal On-Scene Coordinators of the Coast Guard. So in support of that mandate, the Emergency Response Division provides 24-hour-a-day, 7-day-a-week response, scientific support for response during spills. The scope encompasses the entire coastline, including the Great Lakes, Alaska, Hawaii, and U.S. territories. So whether the spill is in the Gulf of Alaska, the Gulf of Mexico, or the Gulf of Maine, we need to provide that scientific support. So it's really important for us to engage with the regional experts through things like the regional associations. Those scientific support roles, there's a numerous variety of scientific support roles that scientists from the Emergency Response Division might serve in, from flying in overflights over the oil to map out the surface oil distribution, to looking at the resources at risk for other natural resources or human use resources, shoreline assessments, data management, looking at protection priorities and cleanup recommendations, and then the one I skipped over, which is oil movement forecast, where myself as an oceanographer usually helps out. And that, from the big spills like these ones, which are relatively infrequent, to the much smaller spills like the one we saw in the slide a few minutes ago in Puget Sound, the oil movement forecasts are pretty much our most often or most frequently request for scientific support. The Coast Guard needs to know where's the oil going to go? Is it going to impact the shoreline? What do we need to do to react? Just a cartoon here summarizing some of the processes that are important in predicting an oil trajectory or a movement of oil. And so the main processes being spreading of the oil on the surface due to gravity initially, and then the horizontal ocean turbulence, a weathering of the oil, which is biological, chemical, and physical transformations that take place after the oil is spilled, and then transport by the ocean currents. The point here is that all these processes are highly dependent on the environmental conditions when the oil is spilled. So our key variables for looking at all these processes are the winds, ocean currents, and then temperature. Other variables are important too. I just listed a few to give you a flavor of the observational data that is important to us. And then sorry, I lost my train of thought there. So it's really the forecasts of ocean currents and and the winds that we're using to predict the oil movement. So we can use forecasts of the winds and the ocean currents to run trajectories of oil oil in our trajectory model, which is NOAA, the General NOAA Operational Modeling Environment. I don't want to go into detail about the model right now in the limited time here, but one of the points is that as addition to using our in-house models, we can use ocean currents from external models, Navy operational models, NOAA models, state agency-run models, or some of the high-res regional models that are run through the IUS regional associations, like the one shown here on the right, which is Alex Kropov's model for the Oregon Shelf, which you've heard of already today. And that is a screenshot showing it with being used in our trajectory model to simulate a hypothetical spill off of Oregon. And as far as the wind forecast, we rely on our friends at the National Weather Service for the forecast winds, and we have a great relationship with them where we can call and get spot forecasts tailored for an incident. So I think I can just leave it at that. Obviously, we've heard a lot about the value of observations for improving forecasts, and so we use observations directly in addition to the model forecast fields to validate the models that we're using, for the data it's used for the simulation, for constraining the forecast uncertainty, and also for looking at past movement of oil to validate models. And our big requirement, because we have a scope that encompasses all these different areas, really the idea of this one-stop shopping for observational data is really important. When you get a call at 2 in the morning, you are not going to spend time looking at a broad, spectrum of different sites for data. You really want to be able to pull it all together quickly. And I'm going to stop there.
Thank you all. A very fitting way to end our discussion sessions of the day with a very operationally focused panel from search and rescue to crossing what is clearly a demanding riverine bar system to actually how do we go about protecting lives and property from oil spills and other hazardous materials that we can model. Thank you all very much for that very good discussion. Some questions, please, for our panel. Chris Morris in the back. Hold it, Chris.
The Coast Guard has done very well with quantifying their requirements for environmental information for search and rescue. Is your group ready to do that? Because that'd be a big help in designing the evolution of IUs if that was the case.
I think it would be very tough because of the broad spectrum of events that we deal with from, I mean, not that search and rescue applications aren't diverse, but with the different oil types and chemical spills, I'm not sure what that would look like.
It might be worth looking at what the Coast Guard does to quantify their requirements, and I bet you could make a stab at it with the understanding that it'll improve as you evolve it over time too.
Absolutely.
Yeah.
I have a general search and rescue question. Sorry, Bill, real quick. It's either for the commander or Stenka or Mike Cosrow or some combination thereof. But on the East Coast, the feasibility studies that looked at CODAR information and improving search and rescue trajectory tracks, is that going to be exported nationwide, or is that going to be, yes? Stenka, hold on.
So the answer is yes. Under development from IUS, the short-term prediction system, which is that forecast that SAROPS needs, has been developed for the regions where we have HF radar. And we work with Art Allen, who is at their research center in Connecticut, Art in Connecticut, who developed SAROPS. So what has to happen in an operational mission is it's on the developmental server. And then the Coast Guard will bring that into their operational system by releases. And then the training has to occur. Now, as a Coast Guard area commander, they have access to the environmental data server that is not the operational, and they can get to that. But we are close to bringing the entire, where we have HF radar, this SDPS short-term predictive system, into the operational center for the Coast Guard, so you'll have access to it from SAROPS, because right now here on the West Coast you still have to go to your developmental server. So that's what we're doing at the national level. And then I'll let you take for what you're doing at the level here.
Thanks, Stenka.
Sure. So I think that's actually great to hear, because for us, every step we can take in the direction of getting more accurate data and better representation that better data that feeds into the model, which then represents where whatever object we're searching for would drift, it just makes our searches that much shorter, and especially here in the Pacific Northwest, where I was actually on the NANOOS iPhone application a little while ago, which is great. I hadn't downloaded that before today. That's fantastic. But looking at the water temperature at the La Push buoy, and I think it was 43 degrees right now. The survivability rate, unless you're in a life raft or even in an anti-exposure coveralls or Gumby suit, is pretty short. And so the quicker we can find someone, the better. Just from my observations out here, I've been out here about 7 months now. Our offshore data is actually very good. When we're searching, generally where we end up finding it is where the models are telling us. Where we run into challenges is inside of Puget Sound, and part of that is just the lack of data, but part of it it's just a very geographically diverse area, and trying to model the Hood Canal or the areas up in the San Juan Islands where there's just so many inlets and diverging currents, winds, and everything else is challenging. And I don't know, I'm not certainly a scientist, but I don't know that we're ever going to be able to crack that nut, but we're certainly getting better.
Man. Bill?
Bill Berkmeyer with the Corps. This is for Dan. The compelling tale because of observing with an direct application. One question is, how close are we to the right result? In other words, you said, you got to have 10 hours. How often do you blow it with the information you have?
That's a good question. Well, we haven't hit the bottom in a lot of years, so we haven't blown it, in my memory anyways. If anything, I think we're blowing it on the conservative side. So ships that could sail, they're losing a little bit of money because we're being too conservative. But I'd rather err that way. The study that we're doing right now, we should have results out on that this fall, and it'll actually generate a computer program that will give us a better tool to work with.
David Jones, back here. David,
Hi, David Jones from APL UW. This is for Captain Jordan. Just curious on where does that decision get made? Is it made first by just the pilot that's going to be going out with that ship, or is it done at a center? Because I was wondering, you have a lot of different data, and there's probably some experience in putting all that together. I mean, have you been able to fuse all that in kind of a fusion center?
Well, it's both, the pilot going out and a center, but the pilot going out is at that center. We're a really small group. There's only 14 of us, 7 on duty at a time. When a storm's approaching, we usually have at least a day, sometimes more, notice that it's coming. And as it gets close, a few of us will get together and make that decision. But once the ship's sailed, you're pretty much committed to go. There have been a few ships that have anchored because a storm has stalled, but the ship was going, and you have to err on the side of safety. So you can anchor in the channel, but the Coast Guard doesn't like that.
Thanks, Captain. You, sir, and then you're next.
Jerry Joyce, Moon Joyce Resources. There's been a lot of discussion about getting real-time data, how valuable it is to see it immediately. But, for example, when we have an oil spill, you're modeling away, but those things aren't out to the public. They're out to the Joint Information Center who releases it, and maybe we'll get it that day, or maybe we'll get it a day later. Shouldn't, if you're using all this data, real time that's coming from all these different organizations, shouldn't the result, your products, be available also freely rather than have it censored through the Joint Command?
I agree with you, and I think that was the case in Deepwater Horizon after the first few weeks. I think that in a lot of cases with things like the surface oil forecasts, the event's over within, for the typical spills that we do, by the time it's asked for, basically the incident is over, the oil's on the beach, we're not producing them anymore. But I think because of the attention and the demand for those products during Deepwater Horizon, I think that they will be publicly available in the future. And then certainly the satellite analysis that was done by NOAA NESDIS, they were putting that out as well in near real time. I think the public was getting it at the same time as us later in the spill. So I think it was one of those questions where no one had asked for it before. But I'm fairly new to hazmat, so I don't know if your experience is different.
Like you said, you need the information within the first few days, but it took weeks for that. If it's not institutionalized now, it's going to take weeks again before it gets released out to the public. So, I mean, I hope that it becomes institutionalized so that we can have it. We have our own, I work with Audubon, so we put people out to scope out where the birds are and report that actually back to the agencies. And without having the real-time data, we'll never know where to go. So I hope it becomes institutionalized.
And I could provide one perspective from the FOSC, the Federal On-Scene Coordinator, for an event. I mean, we don't even have access to real-time. There's no real-time click a button, get a beautiful model system, at least that we use right now. I mean, when there's an event or an oil spill that's going to require the stand-up of an incident command, or even one of the smaller events, we actually use scientific support from NOAA for the landing craft just in the slide I showed. They actually sent someone down to our command center. We actually, as a Federal Unseen Commander, will submit the request for a specific analysis to NOAA. They have to do that analysis. Once we receive that analysis back, and oftentimes they are in the command center or the incident command with the Coast Guard, the state, the responsible party, everyone, then that immediately gets released out as part of either a press release or just for larger events. We'll actually have, there'll be some sort of a website stood up for that. So I would say it's released as close to real time or near time as the person that's going to be using that for actual operational command and control is getting it. And especially for future large-scale events, I think you'll see much better reporting in the future.
Thank you.
Hi, I'm Brian Zelenke here with NOAA, and question for Captain Jordan. You mentioned an interest in currents in the Columbia River Bar, and I was wondering if you could comment on the utility of the CODAR CSON HF radar surface currents measured in that area.
I'm not aware that they're doing that on the Columbia River Bar. You are? Is it on the NANOOS site? I'll look for it.
May I pass the microphone
Okay.
to Dr. Mike Cosrow?
Yeah, we are making measurements of the Columbia River outflow. There, the technique, the HF technique has trouble when the currents get as large as they do right at the mouth. So we don't do a good job when they get up at 3 meters a second. But it doesn't take long for them to come down below to where we are able to measure them, and that's the region that the waves pass through, where you need to do the wave shoaling. So
the modeling that I'm aware of that we're doing is using the currents through the CMOP Center and Antonio Baptista's work. I'm not aware of what you're doing, so I'd like to talk to you more about that.
Absolutely, love to.
Yeah, this is Andy Lanier with the Oregon Coastal Management Program. And I guess I was thinking after hearing you guys talk that I didn't hear anything about vessel traffic monitoring, and wondering if you guys, how you do that, how you account for patterns of movement over time, if you keep track of that, or if you use automated information systems to basically monitor the ships as they're moving up and down the coast or in and out of the river channels.
I can cover part of that. I can at least cover that for Puget Sound. So Puget Sound is one of the areas where there's an established vessel traffic service, which is essentially similar to an air traffic control tower on the water, although they give less direction than air traffic controllers would give to aircraft. They only intervene if there's an imminent collision or something that's going to happen. So for vessels that are above a certain size that are required to be part of that vessel traffic scheme coming in and out of the Straits and Puget Sound, they do track data on those vessel movements, and because they are all have automatic identification system, AIS, on board. We have a series of radars and AIS receivers that essentially allow the Coast Guard to track those vessels from far offshore, and it's a partnership between the U.S. and Canada, because the vessels are handed off as they come in through the Straits. They shift between Canadian waters, U.S. waters, and so it's a joint vessel traffic service. So we share the data between the Canadians and the U.S. on those larger vessels. For smaller vessels that aren't required to be part of the vessel traffic system, we don't have any specific way to track them other than if they happen to fall into some of our other sensors that our Jayhawk happens to have on the water for homeland security purposes. But it's not nearly as robust as with the larger vessels.
Thanks, Commander. And with that, I'm going to have to draw this particular session to a close. I'd ask we thank not just these panel members, but all our panel members that gave such exciting and informative talks today.
Great. Well, thank you, everyone. I'm actually wired for sound already. And so I'm happy to say that I'm standing in between you and a wonderful reception that's about to begin. But I do want to share some words with you. I have 3 things that I would like to say in 4 quick announcements, and they're really important to me. And the first one is the sense of gratitude. And I extend what David said, and on behalf of all of NANOOS, I thank you all, the 150 individuals who chose to spend your time today with us in this room talking about this and giving us your input and your insights. I really thank you for making that decision. We know how busy people are. And I echo what David said about all of the speakers who spoke. It was an incredibly talented bunch of people that we had. We have a beautiful program that is in the lobby that has their speaker bios in it. So I encourage you to get to know these people better because they bring an enormous amount of talent to the region, and I thank them for their participation. And then also we mentioned our organizing committee that put this event on. And they are also listed in this program, and I'm going to read their names because it is these people who every 2 weeks got on a phone call. This event did not happen because, oh, there's a cookie cutter way to do it. It was because of people's really good ideas of how to put that together. Bill Dewey with Taylor Shellfish, Jack Dunnigan of the Army Corps of Engineers, Ken Zimble with the Puget Sound Partnership, Rob Fotlin with Microsoft Research, Mike Cosrow with Oregon State University, Norge Larson with Seabird Electronics, Chris Moores with Portland State University, Jay Perlman with the Institute of Electrical and Electronics Engineers, Steve Rumrill with the State of Oregon, Joe Schumacher from the Quinault Indian Nation, Rick Spinrad from OSU, Steve Usakai from the Boeing Company, and Timmy Van from our NOAA office here at Montlake. They were joined, this is our local group, they were joined by Jessica Snowden from the IUS office out of DC with Stanka Willis, and also our leaders in putting this on through the IOOC, the Interagency Ocean Observing Committee, Ralph Rayner, Nick Rome, and Josh Young. This has been a fantastic team to work with, and I thank you so much. Okay, that was message number 1. Message number 2, we've heard some really excellent feedback today to NANOOS, and what I've heard are some feedback about our successes, and I can't tell you as someone involved in NANOOS how wonderful it is to hear those things, but I really want to underscore that it is the diverse people, some of whom you've heard their names mentioned today, many of whom you have not. And I want to make a point here because the people of NANOOS, I think they sort of self-select. These are not people who are out for fame or ego or money or power. You don't join an ocean observing system for those reasons because those things don't exist. You join an ocean observing system because you think that you might have ideas about how to solve problems, because you think that you might have ideas about how to bring things that are disparately separate and bringing them together. And because you're creative and that you might have good ideas and that you're willing to work well with others. And I've been involved in a lot of projects, some leaders, some as a partner, and I have to tell you that being the director of NANOOS is one of the things that gives me the best pleasure in terms of working with people. We have good people, and that's what makes NANOOS what it is. And so I want to thank them, and I want to welcome you all into the collective NANOOS family as you see fit and as we go forward. Okay, we also heard a lot about challenges, and to be quite frank, some of our most difficult challenges came right in that first discussion. Money, problems of data quality and how to assure these things, and then also that crevasse with science policy and the struggle there. Okay, these are not new problems. These are pervasive problems globally. But these are problems that I have heard from the IOOC leadership co-chairs, from Stanka Willis, director of IUS, and from NANOOS that, okay, you know, in a way, can I say it? Damn the torpedoes. You know, we can't just give up. So what kind of a nation do you want to live in? What kind of a nation do you want to build? And so these are real problems. They're difficult to address, but we have to do our best, okay? So we're going forward with those. And what's exhilarating to me is that I'm hearing that from the highest levels down. And I really want to thank the IOC for their leadership in that. All right. There's other challenges, though, that are maybe the next level down. And we heard some of those today. Things like the time scales differences and the connections, how to better reach our audience, how we can improve on our products, both in the short-term sorts of things that we can be doing now and in the long-term things that we can be doing now. And those are really exciting to me because those are some things that we can put some great creative energy into this. This workshop is not a one-off. It's not a one and done is what I meant. This is the start, okay? And for many of you, about 50 of you, you've chosen to spend another day with us tomorrow. We're going to start having those conversations. But we're not going to end there, okay? This is an iterative process. We need your constant input to it. And nurturing. So I'm excited. So that's my third message is that we've heard about our successes, we've heard about our challenges, and I summarize this last part up by saying that despite what the calendar says, this is not Groundhog Day. In the sense of that silly movie we're all thinking about. This is definitely not sticking in our mode and just doing status quo. So I thank you for that energy, and I know it's going to continue. So, well, I've got your mention on Friday. I want to call your attention. It is also in the lovely program. We have two things going on tomorrow. We're going to be in a different building. This is building 33. There's a building 99, right? Yes. And we're going to be in building 99, and you've all got the directions on how to get there. We're going to start at 8:30, once again, with Rob Fotland with Microsoft Research, starting a session on new collaborations. We heard a lot of really cool ideas, and this is a wonderful think tank. Let's think about some of these new things that we could maybe do together. All right, so that's our first session from 8:30 to 10:30. Then we're going to take a little break, and from 11 to 1, we want your ideas on enhancing observations. We've heard a lot of ideas thrown out today, and we've heard some things that I know people are sitting on and they're thinking about. Things about how to achieve optimum integration, things about how to encourage wider participation, and things about how to secure and sustain the improved engagement of all users. So that's what we're going to focus on tomorrow in our Friday morning. And then we're going to really get a treat because one of our co-sponsors of this event, Seabird Electronics, who has a wonderful display in the back there, is going to have a lunch and open house at their facility, which is very close by. And so I encourage you to visit the folks back there at the Seabird booth. They're going to give tours. I'm sure it's going to be a wonderful time. They're incredible hosts. So I want to conclude by thanking not only Seabird, but our other sponsors. I always say it wrong, Sonardyne, sorry, and Reed Exhibitions, who have been very generous in their sponsorship of this, the Puget Sound Partnership. And I have to conclude, last and certainly not least, Microsoft Research, Rob Fotland, thank you so much for your representation of your company and your goodwill in working with us to get this going. Not only is this a wonderful venue, it's you have recycling. You have a healthy environment. You have a place that your generosity is, you know, you go around the corner and there's a nice soda that you can have. And this is just a really fertile and wonderful, your hospitality has been great. We thank you for that. I know that you've got a reception waiting for us, and I can't thank you enough. We look forward to this continuing intellectual enterprise here together, but thank you very much to Microsoft Research. So thank you all.
Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.